Okay. Step 1, you want to choose the variable you want to get rid of. So looking at these two equations, I want to get rid of the x because this is 2x, this is 2x. The number in front is the same. So what if it's not the same? Then we can make the coefficient in front the same by using lowest common multiple. So in this case, since it's already the same, we can skip this step. Okay. Obviously, the next example is when we have to multiply using step 2. Add or subtract to get rid of the variables. So does 2x plus 2x get rid of the variable? No. Does 2x minus 2x get rid of the variables? Yes. So that's how you know if you should add or subtract. So let me just rewrite this I'm just rewriting the equations. Now I'm going to subtract both equations. So 2x minus 2x, that's gone. Negative 3y minus 2y. Negative 3y minus 2y, you get? Yeah. Negative 5y. 5 minus 10? Negative 5. Yeah, so now, no more x. If you do elimination correctly, after this step, you should have only one variable left. If you still see an x and a y, that means you did it wrong. So now negative 5y equals negative 5. When you divide that negative 5 over, that means you just solve for one of the variable. You solve for y equals 1. Okay. Just like yesterday, same step. Once you find one variable, you can substitute it in to find the second variable. Doesn't matter which one I substituted in. Doesn't matter. It's you're looking for the intersection point on these two lines. So let's say I substitute y equals 1 into the first equation. Actually, second equation is better. Into equation 2. So 2x plus 2, instead of y, I'm going to stuff in the 1 equals 10. Okay. 2x equals, move that over, so you get 8. So x equals 4. So using the method of elimination, what is my POI? Yep. 4 and 1. Good job. Yep.
So you don't use elimination for x, you just use it for y, right?
Yeah, you can't. Let me rephrase. So right here, we use elimination to eliminate the x to solve for y. Once you have this, you can use the substitution method to find the other variable. Right here, if I use elimination to solve for y, I'm gonna if I use substitution. If I use elimination method to eliminate the y's, then that means in this step, I'm going to solve for x. And then at the end, either way, you would just substitute that value into either equation.
Then we just do, I didn't do any substitution, where I just did it twice.
Oh, you did elimination twice?
Yeah.
You could do that too. Yeah, that's fine. Yeah.
Wait, so how do you do step 2?
Oh, step 2, for this example, we didn't need step 2 because it was already the same.
Eliminate y, we would have to use step 2, right?
Yeah, that's actually example 2. Yeah. Okay. So the good thing is, yeah, at the end, it's still substitution. It's still, that's the fastest way, easiest way. You're just subbing a number into the equation. I'm not trying to make your life difficult. I'm trying to make math easy. So this is the simplest way. Hazel, question? Or it's okay. Okay. All right. Okay. Example 2. Find the point of intersection of the linear system using elimination. Okay, so now looking at my equation 1, 2x minus 3y equals 5. And equation 2 is x plus y equals 5. All right. So let's choose a variable. Do we want to get rid of the x or do we want to get rid of the y? So for the sake of the lesson, I'm gonna get rid of the y this time, all right? Because we got rid of the x in example 1. Let's get rid of the y in example 2. Okay. So looking at my coefficients, I have -3, and what's my coefficient here? Yeah, 1. Yeah. When you see y, it still has a coefficient. It has a coefficient of 1. So I'm gonna force it. I'm gonna force it to match up for my coefficient number to match. What do I have to multiply everything by? Yep. You can just multiply by 3, actually. So if I multiply everything by 3, 3x plus 3y equals 15. Okay, I know what you're thinking, right? So just hang in there. I will answer. I will explain in just 1 second right here. Okay, so for the first equation, I just copied it straight over. Okay, I didn't need to change anything. Second equation, I multiplied everything by 3. Now, yes, I was thinking, what I was saying is I want the coefficient to be the same. Right now, are they the same? Is -3 the same as +3? No. So they're not exactly the same coefficient, but remember the method of elimination is we want to eliminate the equation. So can I add or subtract to eliminate the y's? Yeah. By adding. That's right. If I add the two equations, I can get rid of the y. So technically, it doesn't have to be exactly the same coefficient, but as long as the number is the same, we can get rid of it. So 2x plus 3x is?
5x.
5x. -3y plus +3y. What happens to it?
Yeah.
Yeah, they're gone. Eliminate it. That's why the word elimination. And then 5 plus 15? 20. Yes. Thank you for answering my question. All right. And so what is x then? 4. That's right. Okay. Now I can use this. I can sub x equals 4 into either equation. Let's do equation 2 because it's nice and simple. So 2 plus y equals 5. So y equals 3. So what's my POI in this case? Oh, sorry. I made a whoops. Yeah, it's a Wednesday morning. It's a 4. Yeah, x is 4. So when I substitute it in and subtract, this is y is 1. So what's my POI? 4, 1. Anyone notice anything? Yeah. As example 1, example 2. Yeah. What do you notice about example 1 and example 2? What are these two linear systems called? So take a look. Why did I get the same answer as example 1 and in example 2? Compare the equations. Compare the equations. Here, I'll do this so that you guys can have it side by side. Okay, so this was example 1, this was example 2. So the first equation was exactly the same. What about the second equation? Yeah.
Just divide everything by 2.
Yeah, it's just divided everything by 2. Or you can say it's multiple of 2. So what is this called? When this system and this system equivalent linear system. It's actually written right here. Okay. So when one equation is just a multiple of another, we just call these equivalent linear system. So it's essentially like basically the same equations. We just solved it twice.
But the POI do the same for different lines as well, right? Not all.
But then it won't be equivalent linear system. Equivalent linear system means like these two lines
Have the same equation.
exactly the same equation. So not just the point of intersection the same, but the equations have to be the same. Okay, and look at the equations. 2x plus 4y equals 8 and x plus 2y equals 4. What is the solution to this linear system? Okay, so what if I give you a new system and I give you these two equations? What do you notice about these two equations, Paul? They're equivalent. So notice this whole thing is just a multiple of 2. So when I graph this, what am I gonna see? If I graph this line and this line, it's gonna be the same line. So when I graph it, it's the same line. And so these are called equivalent linear equations. Okay. And here's what is the solution then? Yeah. Exactly. So imagine you have a graph. So this is my first line. And the second line is also like this. What's their point? So my question, so solution, another word for solution is what is the point of intersection, right? So where do they cross each other? Every single point. So therefore, equivalent linear equations have infinite solutions, which means that every single point they intersect. Okay. While we're on this topic, what if two lines are parallel? If two lines are parallel, what is their intersection point? Right? Doesn't exist. There's no solution. So if two lines are parallel, there's no solution because they never cross. They don't cross. And then if the one that we're used to seeing, like this, for example, where there's one intersection point, we say that there's one solution. Sorry? Yeah, and then if it's the same, then it's infinite solution. So that you always have the 3. No solution, one solution, or infinite solution. Can you have 2 solution? Sorry? Yeah. Good. So there's no 2 solution. It's either 1 or infinite or none. Okay. Any questions? Okay. So quick lesson today. It's a Wednesday, lead start day. So I always like to give you guys at least half an hour to work on the homework in class. So you have exactly half an hour right now. Perfect. So I'm gonna go to our homepage, content, and linear system. Catherine, where do you think we will find today's homework? 1.3, exactly. Good job. 7 pages. First 2 pages is the handout that we just did. These are the questions that you have to do. 1, 6, 3 AC, 5 AC, 8 to 10. And the questions are on page 3, 4, 5, and 6. And then the last page, just as usual, are the answers. All ready? Okay, so that's it for chapter 1. Yeah. Okay.